Let's talk about equations as being both functions and relations. So we're going to dabble a little bit with editing our domain for some of these and then actually sketching a graph for these linear equations. So let's look at the first example. So we're asked to find the table of values for this specific domain, and then we're going to graph that given function. So let's have a look. So for the values that they give us, the domain is -3, -2, 0, 1, and 2. So what we are going to do is we're going to plug in all of these corresponding x's into that given equation, y equals 4x, to figure out what the range, the output is. And so everywhere we have an x in our equation, y equals 4x, we plug in that specific x value. And then that gives us the y's. We take that product. And so this would be the result of our y values. And lastly, they're going to ask us to write these as an ordered pair. And the last thing we want to do is we want to plot those points on our coordinate plane. And remember, the x's go horizontal and the y's go vertical. So you'll notice for -3, -12, we're a little off of the grid because there is no -12. So that point would be somewhere here. And then we plot the other points. We're going to the left 2 and down 8 for -2, -8. 0, 0 would be right here. That's the origin. And the next coordinate is 1, 4, to the right 1 and up 4. And lastly, 2, 8, over 2, up 8. And you notice because our domain are just specific points, this would be the graph of our function. So you'll notice for problem 2, they're asking us to solve for this function given those domain values. It's the same idea even though you're not given a table. You're going to plug in all of those respective values into x. And then from there, we would write that as an ordered pair because what we were looking for was the range. And there is our function. Something we're frequently asked to do is to solve for y in terms of x. This is similar to what we did when we were solving for our literal equations. That just means we want to get y alone. So if we see this problem, we want to isolate y. The first step is we would subtract 8 from both sides. And when we do, we would have 4y equals -8 plus 24. If you wrote that as 24 minus 8x, that's fine too. Next, we divide all of our terms by 4. We want to get y by itself. And you notice every term gets divided by 4. Every term. And that leaves us with y equals -2x plus 6. So we will eventually start graphing all of the equation and not just a select order pair. So let's go through the steps that we'll take. In this example 4, we're going to graph y equals 1/2 x plus 1. So the first step is find some values that are easy to plug in. I specifically chose this equation because sometimes those values are easy. We're going to use the values that are easiest for us. So we'll keep going and you'll see what I mean. Then we're going to find the corresponding y value, those ordered pairs, and we're going to plot the points and connect the dots. Now, let's start with step 1. I'm going to pick values to plug in. But you'll notice if I plug in 1 or 3 for x, I end up with a fraction. So I might choose values that would eliminate my fraction, like these. And you'll see that they are also spread out enough so that I can see the shape, the general shape of this equation. Next, we plug those values into our equation so that it looks like this. Our next step is simplifying that y value so that we can find the range of these few select ordered pairs. And we have this. Next, we write these as our ordered pairs, and we plot those points on our graph, and we can see the general trend of this line. I don't have a straight edge. I'm going to make it up. And our line would look like this, going through all of those ordered pairs. When you have a ruler, it looks nicer. Lastly, I am putting arrows on this line to imply that this graph goes on and on infinitely in both directions. If we look at problem 5, we'll notice that this is not y written by itself in terms of x. So here, before we make our table of values, we want to get y by itself. So let's move that 2x over by subtracting, and you'll notice that I'm writing it as 5y equals negative 2x, and that 10 is positive, so plus 10. Next, we want to get y alone, so we divide every term by 5. And that cleans up to give us y equals negative 2/5 x plus 2. So now, when we're choosing these x values to plug in so that we can see what this equation looks like, we're going to want to choose some that will eliminate the 5 in the denominator. I'm going to choose x equals negative 5, 0, 5, and 10. And if I do that and we plug that into the equation, we end up with this. So these simplify 4, 2, 0, and negative 2. So I'm going to write out those ordered pairs. So they look like this. And let's plot them on our plane. So when we see them plotted, it looks like this. And now we just take our straight edge, which I do not have, and we connect the dots. And it looks a little something like that. Lastly, the question that asks which of the following ordered pairs are solutions. What we want to do is get our y by itself. Next, we divide everything by 5, which gives us y equals negative x plus 4. So the next thing we do is we plug in each of these ordered pairs for x and y. For example, the first one would read, is 2 equal to negative 6 plus 4? I'm plugging in 2 for y and 6 for x. Is 2 equal to negative 2? No, so that is not a solution. Next, we try 0, 4. So we plug in 4 for y, 0 for x. So does 4 equal 4? Yes. So 0, 4 is. Then we move to the third ordered pair, and we plug in 8 and negative 4 for our y and x. So we get this statement, which leads us to 8 equals 8. That's also a solution. Lastly, we try the ordered pair negative 3, 1, and we end up with this statement, which simplifies to this, which we know isn't a true statement. So the only solutions are B and C. Those two ordered pairs are on that line. Those two ordered pairs are solutions to this